In this video, we're going to prove an interesting fact. Given that P does not divide N, and N is what's underneath the cube root sign, if P does not divide N for all primes less than the cube root of N, and N is bigger than 1, we want to show that M is prime itself, this number is prime, or N is a product of 2 primes. So, proof. Suppose N is the product of 3 primes. Say P1, P2, and P3. Also note 2 things. Note 1, the cube root of N times the cube root of N times the cube root of N is N. And note number 2, let's not write it in symbols. The cube root function is increasing. Note 2, the cube root function is an increasing function. What does that mean? That means if x is smaller than y, then the cube root of x is smaller than the cube root of y. You take cube roots of larger numbers, you get a larger answer. Y is larger than x, the cube root of y is larger than the cube root of x. Okay. So now, N equals P1, P2, P3. At least one of the primes must be less than or equal to, must be less than or equal to the cube root of N. Why not less than? Well, if all these primes are the cube root of N, we get back N, which is fine. But if you multiply 3 of them, they can all be, they can all be the cube root of N or larger. Okay. Call this prime. Remember, there's at least one of them. Call this prime P star. Okay. So P star is less than or equal to the cube root of N. By assumption, P star does not divide N, because none of the primes less than this number divides N. Okay. But P star is one of the P sub i's, I going from 1 to 3. Let's see where they are. P star is one of the primes that is in the prime factorization of N. Ooh, so P star divides N. But that's the contradiction. Okay, so the prime factorization of N can't have 3 factors. 3, well, of course they're prime factorization. That implies the prime factorization of N, the prime factorization of N can't have 3 or more prime factors. That is there. Well, that is N has 1 prime factor or 2. Therefore, N is either a prime number or a product of 2 prime numbers. 2 prime numbers. What I'm getting at is N can have 1 prime factor, 2 prime factors, 3 prime factors, etc. But I'm saying it can have 3 or more. So it either has 1 prime factor making it prime, or it has 2 prime factors making N a product of 2 primes. And this is exactly what we wanted to show. If you like videos like this, subscribe to my channel. Like my video, leave a comment. See you guys in the next video. And remember, as always, watch and learn.